the concept of time. So where did it come from? So when you're walking into physics, you are going to be running into kind of the three core foundational or base physical quantities. Distance, and I talked about that. Yeah, I'll put up a link up above there. So distance was one. Mass, okay, is the second one. I can put up a link up above there to mass. And then the third one, which will ground the foundation for you, is this idea and concept of time. Now, when you're talking about distance, so, a path that you can measure from one point to another, you can kind of visualize that, it's definitely physical. If you're talking about mass, again, it's very physical. It measures the amount of matter. Matter starts to occupy a volume, and it can be weighed in some particular way. And, we can look at things that are physical. But time, if you think about it, well, how is that physical in some particular way? Well, time does come from physical processes, and it actually measures how long a process will take. And it is very useful. We often want to be able to figure out, okay, how long are we going to have to wait for something to occur? How long are we going to have to wait for a friend to come by? How long is it going to be, that our heart beats again, for example. And then there's many other things that we are continuously kind of waiting and possibly measuring and thinking about when we look at our time. So if it's right now, okay, at a particular time, I don't know what it is at yours. Maybe let's say if it's 1100 right now, what does that actually mean? Well, all of these things do have a meaning in terms of physical kind of processes. So time is a quantity. It is measurable, and it also relates back to two other physical quantities that we can think about, which are period and also frequency, which you might have run into at some point, okay, in your education before walking into physics. So this whole idea of time, you should be aware of where it came from if you're going to be studying physics, or even if you're not, if you're just kind of curious. Well, the idea of time and relating it back and creating, a unit of time for ourselves to measure how long something actually takes stems back from our Earth. All right, so if you have our Mother Earth, you can take a look, okay, right there, and it looks like it's spinning around. Well, as the Earth spins around its axes, it continuously goes once and twice and keeps repeating, and hopefully will repeat at least for a very, very long time for us, okay, as it swings through. Well, each of those repetitions has been designated by kind of scientists as a unit of time. And of course, as you dive in, you will say that, well, one repetition of the Earth, okay, as it spins around its axes, we have designated and we gave it one unit, and that particular unit we called a day. Now, that is definitely a physical process, and as you can see, it's a physical process that repeats. It continuously repeats. So what that has allowed us to do is compare. Just like we compare when we measure distance or mass, we compare it to something else. Distance, we have a unit, for example, 1 meter. We know how long that is. We can measure other things in comparison to that unit of a meter. Well, now we can compare with respect to time. Well, we know how long a day is. That means we would be waiting quite a while for the Earth to spin around its axes, right, as you would go through. So as the Earth spins around its, beautiful axes, so if I kind of take the image right here, okay, of the Earth, okay, right there, and if I would take that image And now I know that this is actually, spinning around over here, and then it again spins around. So for every one of those revolutions, we know that that unit is a particular day. Now, we don't want to be comparing everything to a day. So what we have done is, well, we have created other smaller units, and we have broken down this particular day. So if this was the length of a day, for example, so if, we would be plotting it, okay, so right here, this would have been a 1 full day, which means that this would have been a 1 revolution, okay, of the Earth going around, okay, so it would take us this long to wait for that revolution. We started to break this down, and we said, well, we're going to break it down into pieces, and we don't really like to compare things to a day. So we said we're going to have 24 pieces that we're going to divide this day into. So, we could divide this into 24 pieces and so on. So now we have a different unit, and of course, you can gauge that 24 was actually hours, so sometimes we'll just write it as H or HR for short in terms of a symbol for that one unit. So now, the revolution of one Earth, well, so it would be into 24 pieces. So if those 24 pieces or 24 hours goes about, that means it meant that the Earth just went once around its axis. Well, an hour, right, also became relatively long for us. So, if we took this one little piece, okay, right here, I'm going to kind of extend it out, okay, and, so if we stretch this little piece out, okay, so from the beginning, to the end, and let's say that this was 1 hour, that also seemed, sometimes a very long time to wait, especially if you're a kid, waiting for something to happen. Okay, so maybe opening up your presents or something like that, you're kind of eager, and that time doesn't seem to tick away too quickly. So what we have done is, we said, well, okay, so let's take this 1 hour and conveniently divide it up into 60 pieces, and we of course called those 60 pieces minutes and designated as MIN, okay, for minutes for short. So 1 minute again is another unit. So this happens certainly with distance. We have different units, okay, depending on how long the path is that we're traveling on, right? Or maybe if we're measuring something, an ant might be very small, we might need very small units. Well, time works the same way. Well, how much waiting are we doing? A day, an hour, a minute, and of course, if we've gotten into minutes, maybe you're playing sports, and your sports like the 100-meter sprint is not going to be waiting a minute, so it's not convenient for us to do that. And therefore, these little 60 pieces that we're dividing this hour into, all of a sudden, again, gets broken down, and we stem it out, and I'm going to kind of blow this up as well. And that one little piece, okay, which is 1 minute now, has been broken down into even smaller pieces, which we call seconds. And these seconds, okay, so designated as SEC right here in terms of the shorthand for it. So of course we're very familiar with this, especially if you're just diving into physics. This isn't really anything extraordinary for you. But what might be extraordinary for you, now you understand where this definition of time has come from. So this particular definition of time really has come from the rotation of the Earth spinning around its axes. And that's what we have right here. And of course, these are the most common units that we use. Now, of course, depending on what you want to measure, you of course can go higher if you're waiting a long time. So maybe from a day, then we constructed a week, and then we said a week was 7 of these days, right? If you're waiting longer, maybe it's 1 month. Right? And well, the months vary depending on which month you have, but you know how many days are consisting in a January and so on. Then, maybe that's even too short in terms of month. Maybe then you'll go into years, right? And years is a certain amount of days that we have. And then maybe year, turns into decades, which is periods of 10 years, and so on and so on. So it just depends on how long of waiting do you want to be able to do. But time is indeed a physical quantity. Now, what is very interesting, for some students, you may or may not know, so because our Earth is rotating around its axis, we also, just depending on where you are, but even if you're, closer to the equator, you still have some sense of changes of weather. And that happens because our Earth starts to rotate around the sun. And that also is a repeating process, right? So we say that it takes one full year. So for the actual Earth, to circle around, and it goes around its sun all the way through, and that takes 1 year. Now, you may or may not know, that 1 year, okay, depending on when you are dealing with it, sometimes it takes 365 days, and sometimes it takes 366. And you might say, why does it switch? And it actually switches every 4 years. Okay, you may be aware of that. So every 4 years, we have an extra day. Well, it doesn't really happen, right, that the Earth, because that's a physical process where it goes around the sun, it is not really, exactly, 365 or 366. Actually, the Earth rotating around, it takes about 365 and 1/4 of a day. That's how long a year is, approximately. But, we can't have 1/4 of a day in a year. We want it to be in days in our calendar. So what we do is, as you can see, well, you are going to take these. So every single year that passes, well, every 4 years, all of a sudden, when you're taking 1/4 and then another 1/4 and another 1/4 and another 1/4, well, you end up with, an extra day. And that's why, every 4th year, we have an extra day and we plunk it into February, for instance. So it doesn't take us off course. So now, maybe that's a, nice little trivia item, but at least now you know why we have that 366, and the other, 3 days out of the 4, or sorry, 3 years out of the 4, we have 365. So that's what happens, but it is meant as a physical process. Now, what's very interesting is that, we can also think about, in terms of these processes. So if I go back in here, I've mentioned period and frequency, and what the heck were those, right? So in terms of a period and a frequency. So when you're thinking back of the Earth and it's rotating around, well, one rotation, right? So it might take 24 hours or 1 day. Well, we call that a rotation a cycle. So in just general terms, so one particular, rotation of something, we call a cycle. So that particular cycle in the process just keeps repeating, right? So we spin around, and then we spin around again, and we spin around again. So we have these cycles, and we can count, so how many of these rotations happened? Well, it's easy for us to know that, if in a year, as we're going through, or the Earth is not only spinning around its axis, it's also going around the sun. So we can count these cycles. Now, these particular cycles happen in nature quite often, right? So you have a very important cycle, right within your heart. So, the heart just keeps beating. Now, that's a repetitive process, hopefully. Yes, of course, sometimes it speeds up and slows down. So it's not exactly kind of constant like the Earth rotating around. So the heart obviously gets changed. But if you take a, short enough duration, we can actually see these cycles, go through. So that's a nice venture, and I have here kind of a monitor screenshot, okay, within here, and you can see that this monitor just shows us, a beat of the heart. And, this is where, okay, this peak right here, so from here to here, this is where the heart kind of pumps out the blood, right? And it happens every so often. And you can see that, it pumps out, and it just tries to relax, reloads again, and then it pumps out again, so it pushes out. And these are just a screenshot of just telling us the amplitude, the strength that the heart is pushing these things through. But of course, these things are happening every so often. So within here, I've actually kind of copied it down, so let me bring this back in here so, we can, since this is now related to something very physical like the heart, we actually say that if we do have these repeating processes, if it's the earth going around or if it's the heart pumping in, we say that the amount of time, so for example, so from here, right, to here, you notice that after that, it just keeps repeating, right? So and then it repeats again, and then it repeats again, and then it repeats again, and so on. So you have these repeating processes. So here is, one cycle, this would have been 2 cycles that passed by, 3 cycles, 4 cycles, and so on. So these would be the amount, okay, of cycles, and we can count them, or like the earth, how many rotations did that occur? So that's fine. So those are cycles, easy to understand. Now, that cycle, you might say, how long did that one cycle take? Now, when you're saying how long it takes, you're referring to time. But now you're referring to a very special time. And within here, so the length of time that we have, so as you're going through, that takes us for one particular cycle. So if you're going to take this, instead of calling this time, of course it still is time, but it's a very specific time, we actually call this a period. And the period is the amount of time that you have, okay, per just one cycle. So that is what we would have within here. So, how much time does it take for this one cycle? Now, we have these, right, in terms of how much time it takes per one cycle. And we would write it out. So a period is designated with a capital T. If you would put a formula on this, time is actually designated with a small t. And very often, we'll do this, okay, and then we'll just write C for cycles, or you can write out the full word. And you would notice that this is the amount of time that it takes. Now, for a heartbeat, it's going to be a short period of time, depending maybe how fit you are and then what you're doing. Maybe it's a second, maybe it's a little bit less, maybe it's a little bit more, okay? Again, depends on your health and so on. So that's a period, okay? So, period basically tells us, how long, okay, do we have for one particular cycle to occur. So it measures time. Now, very often, when we're interested, not just in the period on how long it takes, we might say, okay, well, here's a certain amount of time, maybe a minute, all right? And now, a minute passes by, and you might say, okay, well, so here's, maybe, okay, if I'm going to draw this out, so here's, okay, a minute that passes by, so from here to here, and this is 1 minute, okay, so that's the length of time, that's 1 unit. And you might say, how many cycles have happened here, So how many cycles, as you're going through and so on, so maybe these cycles are repeating, okay, every so often, or maybe it's super slow and there's no cycles, or maybe it's just a fraction of a cycle. But if you're thinking of the heartbeat, okay, and you go in here and you say, well, okay, a heartbeat, well, now instead of saying a cycle, we're calling it a beat, right? Because the heart is beating, like we're thinking that it's just beep, beep, okay, right, as it's going through. So you might say, how many of these beats or how many of these cycles have now happened, okay, within a certain amount of time? And that, okay, is called frequency. So frequency, which is how frequent, right? something happens. So for frequency, we designate it with F. And instead, okay, we are interested in how many cycles we have, so the number of cycles, okay, per a given unit of time. So that's what we have in here, and that's a nice little small formula. And now notice that your period right here and these are just reciprocals of each other. They're just swapped, right? So if you ever studied fractions, reciprocal just means that these are swapped. And indeed, that is the case. So, you can say that frequency is nothing else but 1 divided by your period. Or you might say that your period is equal to 1 divided by your frequency. So those are simple things, and of course, if you look at how we're defining them, then that's what it is. Intuitively, period is just how long one cycle takes, or repetition, or a beat. And frequency is how many of these repetitions you have in a unit of time. And that's what you have, okay, related to time. So hopefully you know where time now comes from, how the units have been interacting with each other, and you know a little bit about period and frequency. So welcome to physics. You're now ready. Since you know distance, mass, and time, you can start deriving quite a lot of things and having quite a bit of fun. Okay, take care, and we'll see you in a future video. Bye, everybody.